For number 21, there are 5 functions given, and we are to find the domain of each, describe the graph, which I'm going to just graph, and label the x and y intercepts. To handle the domain, the 2 main things you want to look out when finding any domain, the values of x that you can put into the function. Okay, so for domain. Okay, don't square root negative numbers. Alright, you can square root positives, you can square root 0, but do not square root a negative. Okay. The second thing is don't divide by 0. So x can be 0 depending on the function, so long as when you plug in the value for x that you don't end up dividing by 0. So don't divide by 0. Okay, so for the 5 functions that are given, the only one we run into a problem with is d. Okay, the domain for... Actually, let me go back to black real quick. So the domain for a through e except d is all real numbers. Okay. Or it can be abbreviated ARN, or in interval notation, negative infinity to infinity. Okay. Okay, so that will be the... So I can pick any number I want, any real number for parts A through E except D. The domain for D, however, so part D, so the thing inside the square root, I can't square root a negative, but I can square root anything bigger than or equal to 0. So subtracting 2 to the other side, that means so long as x is greater than or equal to a negative 2. Okay. Now to graph these functions for part A, let me switch here. For part A, f of x is equal to negative 4. Okay, so no matter what x value I hand you, you're going to give me back a negative 4. So when I graph this, negative 1, 2, 3, 4, for any x value that I hand you, you're going to be down here at negative 4. So the graph of this is just a straight line. Okay, so the x-intercept. So the line I just drew never crosses the x-axis. So x-intercepts, none. For the y-intercept, it's right here at 0, negative 4. Okay, now for b, the function is f of x equals 100 minus 900x, which I'm going to write as, excuse me, negative 900x plus 100. And that way it's in the more familiar form of y equals mx plus b. So my y-intercept is 100. And then for the slope is negative 900, which I can write as negative 900 over 1, or just emphasize a positive 1. Because for the top, in the numerator, that determines going up or down, and since it's negative, I'm going down. For the positive in the bottom, that's right or left, but since it's positive, I'm going to the right. So I'm going to go down 900 units from the 100, down to negative 800. And then I'm going to go to the right 1 unit. So here's the next point, using the slope to get there from the intercept, and then just draw a line connecting them. Okay, now here's my y-intercept, 0, 100, and here somewhere, I still need to calculate this, will be the x-intercept, which is when the y value is 0. So I need to figure out the x value given that the y value will be 0. So I need to take the 100 minus 900x and set it equal to 0, subtract the 100 to the other side, divide both sides by a negative 1, so 900x equals 100. Now I could have done this in one step. I could have just said divide both sides by negative 900, but I didn't, so here we go. Divide both sides by 900. So that means x is equal to, in simplified form, 1/9. So the x-intercept is 1/9, 0. Part C is a quadratic function, which is given as f of x is equal to 5 minus the quantity x plus 20 quantity squared, which I'm going to rewrite again. Negative quantity x plus 20 squared plus the 5. That way it looks like the vertex form for a quadratic. Here's the general form, which I did earlier in a previous problem, separate video. Alright, so it doesn't specifically ask for the vertex, but since we're trying to describe the graph, we may as well go ahead and find it. And as a reminder, so whatever the sign is here on the h, you're going to change the sign. And here you're going to keep whatever the sign says. Okay, so the vertex is going to be going to change the sign negative 20 and keep the sign. Okay, now because of, let me change colors here, because of this negative sign, when it's a negative out front, the graph is going to be face down. If it were positive, it would be face up. So I want this one. Okay, so now to graph this, or to start graphing it. So I need to go left 20 units and up 5. So I'm over here somewhere with my vertex. And because it's going down, the graph is going to do something like this. That was horrible. Let me redo that. There we go. And come down. Okay. So this graph is going to have to cross the x-axis twice. So I have two x-intercepts on this one. And then my y-intercept is going to be over here. Okay, so to solve this for the x-intercepts, I need to set the function equal to 0. So let me do that. So let's see, 5 minus x plus 20 quantity squared is equal to 0. Subtract the 5 to the other side. Divide both sides by negative 1. Okay, give myself a little room. Square root both sides. Since I am introducing a square root symbol, I need to say plus or minus on the right side here. Okay, and if you square root something squared, you just get the thing from the inside. Subtract the 20 to the other side, which I can write as two distinct values. X is either equal to negative 20 plus the root 5, or negative 20 minus the root 5. So here is negative 20 minus the root 5, and here is negative 20 plus the root 5. Okay, so now I have my x-intercept. So now I just need my y-intercept, which is going to be when the x value is 0. Okay, so I need to set the function again, but I'm going to plug in 0 for x. So y is equal to 5 minus 20 squared is 400, so y is equal to a negative 395. So this is negative 395. The function for d, which we already talked about as far as the domain goes, is f of x is equal to the square root of x plus 2. Okay, now so for some background information, there's some functions you want to memorize for parent graphs. In this case, you want to have this memorized, y equals square root of x. Okay, and the graph of this is going to start here at the origin and just kind of rise really slow like. Okay, it's going to keep rising. Even though it looks like it's leveling out, it actually rises forever. And just to see that, what's going on here. So I said previously you can't square root a negative, but you can square root 0. So the square root of 0 is 0. Square root of 1 is 1. I'm going to jump ahead up to 4 because that's the next perfect square. Square root of 4 is 2, and then up to 9 because the square root of 9 is 3. So if you were to plot these, say here's 1, 1, here is 4, comma 2, and then if you plot 9, 3 out further, somewhere over here, say. Right here. Okay, so you want to have that memorized. Now, just like I've been saying on the quadratics, when you're looking inside of something, since it says x plus 2, I actually want to think minus 2. So this graph is actually going to shift, the graph I want, is actually going to shift 2 units to the left, and then go up. So the x-intercept based on this is negative 2, 0. And now I'm just looking for the y-intercept, which is going to happen when x is 0. So f of 0, when I plug in 0, is just going to get me root 2. So there's my y-intercept. And lastly, for part E, we are given the function f of x is equal to x plus the absolute value of x. Okay, now there's two parent functions you want to keep in mind here. So f of x is equal to just x. The graph of that will look like this, just a straight line with a positive 1 slope. And f of x equal to the absolute value of x. Okay, so it's almost the same as the graph I just drew. However, because of the absolute value, like here, the y value is negative. Any value over here on the left side of the origin, the y values are negative, but I want the absolute value. So anything that was negative has to turn positive. So this side is going to go up. And then if it's already positive, like any point over here on the original graph, well, it's going to stay positive. So I get the same graph. So putting these two graphs together, which is what we want, well, if I have a negative value, which I'm marking here in black, it's going to be offset by the exact same value, but positive-wise. And so I just get 0 when I add those two values together. Same with, say, this one and this one corresponding. I'm going to get 0 again. So on the graph I want, anything at 0 or to the left, and I'll do this in blue, the values will always cancel out. But now if I add two of the same values, two positive values, then I'm going to get twice the value. So the slope of the other side is going to be a little steeper than the original graphs. Alright, so there's the graph that I want that goes with this function. And in this case, the x and y intercepts are both the same. So x and y intercept are both 0, 0.